So if this satisfies the commutative property, then we should be able to do this. One triangle 2 should equal triangle. Oh my gosh, it's a square. Okay, either way, the operation should be the same whether you reverse the orders if it's commutative. So let's check that out. 1 in the row. Here, I'm doing this one over here. 1 in the row, 2 in the column. That gives us the value of 2. 2 in the row, 1 in the column. It gives us the value of 2. So that's an example of the commutative property working. It's a true statement. But you really got to check all of them if you want to be sure. So you want to do 1, is a triangle again. 1 square 3 equals 3 square 1. 1 in the row, 3 in the column. That value that's being output by this operation is 3. 3 in the row, 1 in the column. That also gives us 3. Working, right? You might want to check 2 just to be safe. If it doesn't work for even one combination, then the whole thing, it doesn't have the commutative property. 2 in the row, 3 in the column gives us 1. 3 in the row, 2 in the column, that gives us 1. Working, okay? Is there anything else? No, I think it's everything. Okay, so it obeys the commutative property. Does it obey the associative property? Then 1 square 2 square 3, you should be able to change the parentheses and get the same thing. So 2 square 3, that means 2 in the row, 3 in the column, that gives us 1 for a value. And here, we got to do parentheses first. So you got to do 1 in the row, 2 in the column, that gives us 2 for a value. And 1 square 1, if you go to 1 on the row, 1 in the column, it gives us 1 for a value. 2 in the row, 3 in the column, that gives us 1. So it's looking like it obeys the associative property, but like we did with commutative, we got to check a few examples before we have enough evidence to really think that. Let's switch those up. Oh, I forgot. Changing parentheses. Okay, 3 in the row, 1 in the column. 3 in the row, 1 in the column gives us 3. 2 in the row, 3 in the column gives us 1. And then 2 in the row, 3 in the column gives us 1. 1 in the row, 1 in the column also gives us 1. So, I wish I would have remembered what I did before. Did I do 1, 2, 3? You want to try to think of every possible arrangement to make sure. Here, let me go back in the video. I want to see, I'm trying to figure out what I've already tried so I don't do it again. So let's try 3 square. Isn't this going to be the same though? Because it does have the commutative property. 2 square 1. Because all we need is one example that doesn't work and then it doesn't have the commutative property. So if we use our table, 2 square 1, 2 in the row, 1 in the column gives us 2. 3 in the row, 2 in the column gives us 1. So 3 in the row, 2 in the column gives us 1. It's working out. So it looks like it's both the commutative and the associative properties. I've done 3 examples of the commutative property, not the associative property. I think there would only be 3 examples if it obeys the commutative property, because the rearrangement of this parentheses is the same as 1 squared 2 commutative. You get the idea, right? You keep swapping up that order. If you never find anything that's untrue, it's got to be the associative property if you've gone through all the options. So both of these are true for this example.